Today we're going to talk about solving polynomial equations in factored form. So a polynomial is in factored form when it is written as a product of factors. As you can see from these two examples here, we have standard form, where you'll have things where you have the x squared plus 2x, x squared plus 5x minus 24. You can see how we have them going in descending order with our exponents. Factored form is when we show that same thing. So this is x squared plus 2x, but in a factored form where it's the product of two different factors. X is one of my factors, and x plus 2 is the other factor. Well, in this example over here, and we'll be showing you how to do this in a few sections coming ahead, this is, again, a product of two factors, where the first factor is x minus 3, the second factor is x plus 8. That is factored form. But just notice how these two things are the same. That becomes that, and that becomes that. When one side of an equation is a polynomial in factored form, and the other side is a zero, we want to use the zero product property to solve the polynomial equation. The solutions of a polynomial equation are also called roots. We're going to actually see several different terms for this solution as we go through the next coming sections and chapters. But in this section, we're referring to our solutions of a polynomial equation as our roots. So let's talk about that zero product property. So the zero product property is talking about when the product of two real numbers is zero, or meaning equals zero. That means at least one of them is zero. So for example, if I said A times B equals 0, then 1, A is 0, or 2, B is 0, or in theory, they both could be 0. So if even one of them is 0, then that equation is AB equals 0 is true. So we want to use that to help us solve these polynomial equations. So here's how we solve an equation. So here, this equation is already in factored form. So what we do is we would say, okay, so with a zero product property, if x equals 0, then that equation would be true, because no matter what the inside the grouping is, 0 times that grouping is 0. But also, if x plus 8 is 0, then that would mean whatever the x is, if the expression x plus 8 is 0, then again, times 0 makes the equation work. So we actually have two answers here. We have two solutions. So kind of like when we did our absolute values. So here we have one solution is x equals 0, there's nothing else to do. The second one, though, I do have to do a little bit of work, and we just use our regular inverse operations to switch it over to say that x could also be negative 8. So our solutions to that equation are 0 and negative 8. There are two solutions that will make that equation work. If I was to plug in 0, 0 times 8 is 0. If I was to plug in negative 8 in, I would get negative 8 times 0 is still 0. So we have two answers. So let's move on to the next one. This is also in factored form already. So again, the expression x plus 6, if that was to equal 0, then the whole equation is fine. And if x minus 5 was to equal 0, then again, it would make it also work. So all I have to do is then move the numbers to the other side. So x is a negative 6, and I move the 5 across to get x equals 5. So my solutions are negative 6 and 5. And again, it's important that we have both of those solutions or roots. So here's just a standardized test type of question where you'd have a multiple choice. But again, this is in factored form. So because it's already in factored form, all I have to do is say, well, 2a plus 7, if that was to equal 0, then the equation is fine, or 2a minus 7, if that was to equal 0 with the zero product property, then that would be okay. So here we have a little bit more work because we have to do a multi-step equation. So I would subtract 7 first. I get 2a equals negative 7, and then I would divide by 2. A equals negative 7 halves. We again can leave it as a improper fraction. And then on the second one, I think at this time I would be adding 7 to both sides. Everything else is going to be very similar at this point. We're just going to have a different sign. When I divide by 2, I now get A as a positive 7 over 2. So that would mean that my solutions are negative 7 over 2 and 7 over 2. On this next example, we have a arch of a fireplace. So we can kind of see the arch of the fireplace with the fire in the middle. And the function is being modeled by y equals negative 1/9 x plus 18, x minus 18, where x and y are measured in inches. So again, a couple of important things we want to just kind of start noticing. Inches. The x-axis is representing the floor level. So right down here we're talking about the floor level. It's not up off the ground someplace, right on the floor. We're trying to find the width of the arch at floor level. So basically what we are looking for is this dimension all the way across to there. That is basically what we are looking for. So if I go back to my model, we already have it in function form. So what I'm going to look at here is the negative 1/9 x plus 18 in x minus 18. It's already in factored form. So what we want to look for is the width of that arch at floor level. Well again, so now instead of having a generic y up here, we know what the y is when we're at the floor level. When we're at the floor level, there is 0y because there is no height going up. So we can plug in a 0. Now we have an equation that we can solve. So the first step that I would solve here is I've got to move away this negative 1/9. As I move away the negative 1/9, you're probably going to notice 0 divided by anything is 0. And I'm left with x plus 18, x minus 18. So at this point, now I have a zero product property situation where I would say, well, if x plus 18 equals 0, then the equation is fine. And if x minus 18 equals 0, the equation is fine. So we will be subtracting 18 from both sides to get x equals negative 18. I would be adding 18 to both sides to get x equals 18. So that is the two solutions. So what that is telling me is this. So this point here is negative 18, 0. This point is positive 18, 0 at my floor levels. But that doesn't really answer the question, does it? What the question is asking for is what is the width? Basically, what is the distance between those 2 points at floor level? So if I think about the width, I'm going to go from negative 18 all the way over to positive 18. So that is a width of 36, and inches would be the distance between them. Now as we go on further with all these different polynomials and eventually quadratics, I could also tell you the height of the fireplace at this point. We're not talking about that yet, but one of the things you'll want to start also thinking about is I want to look to find out what is the height. I can very easily still use this function looking for the height of this top peak here. And I would do that by kind of thinking about now having with the x-axis and the y-axis, when x is 0, If I was to plug in an x here, I would get an 18 and a negative 18. I could multiply those numbers together times the negative 1/9 to find out what is the height when x's are 0. And that's going to be what we call the vertex of this quadratic. That's coming later. That's something that we're going to be building towards. But for now, we're using our zero product property and our factored form to help find the solutions or the roots of our polynomial equations.